to joining here and to get in touch with the community again. I'm Joseph, and I'm from Berlin, and I normally study mathematics, and I started to use TouchDesigner about 3 years ago, and today I'm going to speak about the fabric or constraint simulations I've developed over the last month. I think I'll just start sharing my screen so you can see what I'm doing. I hope that works for everybody.
Yeah, works well.
Okay, so I did constraint simulations in TouchDesigner. I think some of you saw it before, and I will try to explain a little bit how I developed this system and try to explain a little bit how it works and how it's actually related to shader programming. Okay, do you still see it if I'm in full screen with TouchDesigner? I guess.
Yep, all good.
Okay, so constraint simulation is basically based on the idea of a simple spring. So what I'm using is basically I have points and they are connected by a line, and yeah, they have some kind of behavior like this. And I can change different parameters like the stiffness of this line, whether it's relatively stiff or very loose. And based on that, I developed more and more complex systems. But this is basically how it started and what's the fundamental idea behind it. So you can see, like, I can, of course, connect several points like this with a line, and they can, again, behave very differently depending on how stiff I set those springs. And I can create meshes maybe to get more interesting structures. And yeah, at some point I've added maybe some wind to it. And of course, gravity is there. I think some of you saw it before, but this is basically showing some examples. I later added like an actual triangular surface to it, so I don't just have the connections, but an actual surface to see. And yeah, this is fairly good, and it's basically a constraint or fabric simulations. People did it before, and I'm definitely not the first to do it. But what I was quite interested in is to see whether I can manage to break the structure. So here now in the simulation, if I increase the gravity far enough, at some point the fabric is going to rip apart. And there was something I've been quite interested in, and I worked a lot to get this running. And now I have a quite flexible simulation tool that can handle all kind of geometry. And yeah, I will show you some more. So from here on, I can have basically all kind of shapes. Here I just imported some model from Houdini and yeah, messed around with this one. I will quickly dive in here and have a look at it. So how it works is basically I just use this is not used right now, a file in, and imported this model of some head and pass it into my constraint simulation, where I have a lot of parameters around and can manipulate its behavior. Like I could make it much stiffer or maybe very fluent, or I could increase wind force and gravity, all kind of stuff. This is maybe a weird example to show it on, but yeah. And again, I have this stress resistance, and at some point it would break. Yeah, underlying again, it's not the surface, but actually this structure of lines. And yeah, afterwards I'm rendering it. So this is basically how the system is built, but I will try to explain a little bit how it works after all, and show you first some more examples I've published before, and people probably saw those. Here I just used some different geometries and played around with it. You might have seen this before. I also implemented the possibility to collide with SDF scenes, so signed distance fields, and use gray marching to render the scene, but also get a collision with the fabric. I don't know what's going on right here. This does not work. Yeah, so I will now try to explain how the system works. I will dive into this operator right here to see how it's running. I want to just show. Yeah, exactly. So basically, as I told you before, I got those. I used the systems working quite generally, so I could use this grid, for example, but I might as well put in a sphere, which should maybe be triangular, and just put it in, and I would get a sphere that behaves like this, however I create it, or however I set the parameters. And yeah, so I will try to explain it with the system and what it has to do with shaders. So I get in my geometry right here and use this part is basically just organizing the data. So I wrote a Python script to transfer the SOP data into different textures, so to be able to work with GLSL and do the whole thing in real time. First of all, I got a texture which stores the information about the positions of my vertices. I don't know if you, who is familiar with this concept, but normally, of course, you have, for each pixel in your image, you have red, green, and blue, and maybe alpha information. And in my case, I use these red, green, and blue information as the X, Y, and Z coordinate of my vertices in space. So TouchDesigner, since sometimes now, I will just quickly visualize this. Since some time ago, you can now right-click on whatever image you have and say view as points, and you will see whatever this texture would look like if you interpret the points as the colors as points in space. So this is, of course, a very important part of my simulation, but also, and a little bit more complicated, is this part, which is called constraints. And this texture holds the information about which points are connected. So I got all those points flying around in space. And in this texture, I get the information about which points are connected by some spring. And I got more information lying around, a lot of different textures storing different information and data for me. But in the end, my main loop, which you see right here, this is the simulation loop, has a feedback, one compute shader, and then this is basically just the feedback loop. And as you can see, the texture that I'm working on looks like this, where the first part of it is the position of my vertices. The second one is the velocity of my vertices. And here I got the information about the connections. Yeah, and afterwards, I calculate the new positions and bring them out to different geometries. I got 3 different kinds of geometries, so I can either visualize the points only, I can visualize the connections, or if I have a surface, I can also visualize a triangular surface on it. Yeah. So I think I'm much faster than I thought I would be. So I'll just try to get a little bit into how it works. So I think it's been Tim Gerritsen who showed me how to work. Like the most difficult part for me while implementing this whole system is to keep track of where my data is stored, and to tell each, like using GLSL, telling telling each pixel where to look at actually. So I run this compute shader not over all these pixels, but only over like once for each vertex, and the vertex will know where to look inside of this part of the texture for its connections, and runs through all those connections, and simply, like, after all, this is the part where the force that results from one spring connection is calculated. So this is basically the most easy part of the whole thing, and is rather about keeping track of the information and where they are stored. I think it's kind of hard to explain it on a general level, because I don't know who's familiar with GLSL and so far, but I'm really looking forward to hear you all in the breakout rooms and maybe answer some questions of you. And until then, I will rather maybe show you some more examples of the parameters I can use. So I will go back to, yeah, maybe this setting, and show you the parameters I have available. So maybe I should look down. 1 second. I'm not able to close the window again because it's blocked by Zoom. Here you go. Okay. So I have, of course, regarding the simulation, the speed of the simulation that I can manipulate. So if I decrease it, it's obviously much slower, and a number of substeps. So I actually solve the whole system right now 50 times per frame to get it relatively stable. And of course, more substeps will result in faster and kind of better playback results. And it's quite performant. As you can see, I think I have right now a mesh with 150 times 150 vertices. And I'm able to simulate this with, let's see, I think 500 substeps, and I'm still at 50 frames per second. So it's fairly quick. And then regarding the fabric itself, I have a stiffness parameter, which tells me how flexible the springs actually are. So if I decrease this, it will get, like, it will just fall down and get very flexible. And if I increase this by a lot, okay, right now the fabric just breaks. But I can also, yeah. So now it behaves really rigid, kind of. And I have another parameter which is called rest length scale, which allows me to kind of shrink the whole thing. Or also, of course, the other way around, just relax it by a lot. And then air resistance is how much drag force is applied to this. So it kind of slows down the whole thing. And if I turn it to 0, it will normally like get very noisy after a while. So this is quite useful. I have something that's called that I call collide with SDF. That's what I talked about before, and it allows me to collide the scene, the fabric with a SDF scene. I can quickly set this up. So if I now make the fabric so flexible that it would touch the floor, it will instead lay down on it, because you need to change some code in here. Now it will fall down on the floor and stay there. That's another thing I can do. And yeah, gravity, of course, which just makes it fall down normally, but it could, of course, fall up as well. Now there's no gravity applied, wind force and stuff. So I'm showing you all these parameters. I don't know if it's interesting to you, but what I wanted to say is that I will probably within the next weeks, maybe in a week or so, publish this tool, and I'm very curious to see what the TouchDesigner community creates out of it. Yeah, I get some other playful parameters and stuff, but this is basically how the whole system works. And yeah, I just wanted to present shortly how it works, what you can do with it. I think there are more interesting examples than I just showed. I think I got one more, which I haven't shown yet. Yeah, let me show this one quickly. Now, where is it? Here. Of course, for the TouchDesigner community here, I used a banana. Did it work? Okay, I wanted to grab a banana. Doesn't work right now. Not sure why. Ah, there's one. Here you go. Now we have a banana falling onto the ground. I think that's most important to TouchDesigner. And again, I have like a lot of flexibility on how this behaves. Now the banana is very rigid and bounces around a little, or I could make it quite a fluent, just trim together. And again, like I'm showing you the surface only at this moment, but there's actually this triangular mesh, or rather this number of constraints behind it. It behaves weirdly now. So actually I just got those points in space that you see here, and a lot of those are connected by a line, and this line tries to preserve its length. And afterwards I'm able to just draw a surface on it. And yeah, so this is basically what I've been doing the last weeks, months, whatever. I developed it further and further. And I'm curious to share it with you and to see what you do with it.
We are going to be talking a little bit about building tools and being technology agnostic and how to use TouchDesigner for prototyping. And finally, I will present the shaders from Shadertoy to TouchDesigner to Raspberry Pi tool that I built. So firstly, about me, I'm Danish. I'm New York-based creative technologist and new media artist and VJ, because aren't we all? And I use TouchDesigner, Unity, and Unreal mainly. And I work for a number of different agencies. And I have 2 degrees in computer science, and then I have 1 degree from this fantastic place called ITP NYU, which is a fun, weird place where art and technology meets, and TouchDesigner has become hugely popular. So nobody really knows how to teach it really. So everybody's just doing crazy experiments all the time. And through ITP, I got like very pulled into the shader world, because I've already obviously used shaders in VJing before, and you cannot go to ITP without being sucked into the whole processing and P5.js, and like everybody there, or at least half the people, are complete beginner programmers. So I, coming from my computer science background, decided, well, you know what, everybody's afraid of shaders. Literally all beginning programmers just hear that this is like this crazy topic that you should stay away from and fear, because it's math on speed, which is true. But it's not that true though, because it's also just a really powerful tool and really, really useful to learn as a programmer. So basically, I decided with Casey Quintana, who I went to school with, to make this little you may know like the book of shaders, but we wrote sort of like a booklet of shaders that if you've never ever touched GLSL before, this might actually be useful to you. It's all in JavaScript running in your web browser, but it does explain like why you shaders, what are shaders, how to write a shader, all the important concepts, but like for a beginning programmer. So just one step down from the book of shaders. So if you are here today and you don't know anything about shaders at all, that's actually a good resource. So I thought I would just mention it. And otherwise about myself, I build tools. This is one of the tools I build. I usually start with like thinking about what's already been done before, and then trying to pull that into the shader world, into the TouchDesigner world, or whatever tool really that's useful for the thing I'm building. So here is Jay Tarbell is an amazing artist, and I use this for a project for Candy Stations, who is a visual artist who works for like Sufjan Stevens and St. Vincent, and this is for a music video. And the number one thing before using shaders that I ask clients, the one thing that I need to figure out is like, how fast does this need to go? If I'm making a music video and it's just a recording, it's not going to run real time, then is shader the right way to go? Then I ask myself, like, is memory of pixels important? So when doing stuff like this is like an image processing algorithm that basically samples an image and then draws out lines. And with some parameters, like I built a tool for Candy Stations to use where she can tweak those parameters. So like the curvature of the line, the length of the line, the amount of spread, stuff like that. And this is actually what determines sort of if I make it a shader-based project or not. For this one, it didn't need to be live, so this is actually not shaders, even though it looks like a shader. And then moving on, I already presented this one in the in session that I did with the derivative team last December. But I want to make a good point about this, because whenever I build something, I'm super technology agnostic. So basically, we want it to make these zodiac animals. We also wanted all these 3D model things. I'm very bad at 3D modeling stuff in TouchDesigner. Like I'm Unity and Unreal is like what I use for 3D. And the zodiac animals, so those are real good for TouchDesigner. So choosing TouchDesigner for a task like this and sort of like actually stealing FBX models from Unity that already have the animations that we want, and then just putting them into TouchDesigner, extracting the points and drawing lines, sort of what we just saw Joseph do, in order to make these things. And I also touched upon this in that in session. So if you want to like know more, you can dive in there. But I'm going to speed through these because they're all I want to get to the tool that I built for you guys. So here, one thing that I think is really funny with the TouchDesigner community, since we're talking about shaders today, is that we needed like a certain look for this, which is going to be part TouchDesigner, part Unity. And I think a lot of people in the TouchDesigner community, we tend to think about shaders as like this, oh, it makes a landscape, or like makes a set image, or it's sort of like a flat thing that I can use for VJing. We don't think about it as like a tool to do something. And particularly for this project, shaders were really important for me because it became a way that I could like get rid of the elephant's butt, for instance. So I come from a game design background, and a shader is more than a beautiful visual thing. It's like a way to handle discarding fragments of pixels that I don't need. So for this project, which ended up, this part of it ended up being in Unity, I needed to get rid of like all of these animals, all their butts, so that we could make them into totems, but maintain their animations. So yeah, technology agnostic is super important. Obviously, shaders are used for a range of other things, like VJing. These are MATLAB and TouchDesigner shaders that are being put into LEDs for one of my other projects. Post-processing, I use it a lot for like fluid simulations. So this is, the raindrops are falling. That's just a texture with like more and more black dots coming onto it. But then the shader that does fluid simulation applied onto this, well, just a texture that gets more and more black dots on it, is what brings like a piece to life. But also just for stuff like this, which is using it, you can see like the bloom effect here for emphasis, basically. So shaders, lots and lots of different things. But today, the tool that I have brought to the TouchDesigner community, which I published in, I think, December 2020 on the community portal, and I've since used for some of my art pieces, is this tool where you can easily sort of begin to work with Shadertoy shaders. So this is a piece that I built using TouchDesigner to prototype everything and then putting it onto a Raspberry Pi to make these sort of standalone matrix light sculpture pieces. I have one of them here, which I've taken apart a little bit today, but so basically TouchDesigner goes into a Raspberry Pi and runs this, there we go, this matrix screen. So it might be a little hard to see the actual animation on because it's so bright in here. But basically these are a bunch of firefly animations that are all sine waves in a shader that follows separate rules for how different firefly species actually behave in real life. So when you see them side by side, you'll see that one species of fireflies are following the rule set of like blinking for 6 seconds, then pausing for 6 seconds. Another species is always on. So this is a way to use shaders to sort of communicate rules of nature, which is in this case, a different mating displays actually for fireflies. So this is one of my private pieces. But the tool that I built to make like this sort of piece really easy and really fast for me to prototype is to sort of go to Shadertoy, grab any of these shaders, you know, find a shader that will get me started quick on my prototyping, and then grab that and actually throw it into TouchDesigner. I'm going to dive into this tool in a second, but basically copy paste it into one of these, connect that to this base, which is running some Python code, and then you click make TouchDesigner shader, and hopefully it will convert immediately. If it doesn't, you know, you will have the little nice outputs that for TouchDesigner that says like, you need to fix this one line. But here are some different ones. So it's on the community asset posts, and I think I can't remember. Here we go. It's here, and there are actually videos for how to completely use it. But I will still go through that in a second. And then also how to, there's a secondary part of it where you can click make a Pi shader, and you will make a Raspberry Pi shader for this other library I wrote that runs shaders on Raspberry Pi, together with the Pi 3D people. So this is me putting it onto a Pi and running it here. So without further ado, let's just dive into this. So basically, here's my tool. I have a ton of shaders here that I just basically copy paste any of these and make a new thing. I will go to, I should have one, let's just go to normal shaders right here and just grab any of these shaders. So we can grab this one. I know this one works because I already tested it. But what's neat about this tool is that it just gets me started on my coding so fast. And also just to see if there are any sort of boundaries for what I can do with the code that I am doing. Let's place my TouchDesigner. There we go. So now I have it here. We are going to grab that. My Mac is slowing down here. There, too many. We are gonna grab that and just throw it in there. Hit that, and hopefully it should convert. And what's really neat about this tool then is that I can grab all of this, right? I can grab all of this, I can throw it into a new base and then stack them. So that's what I did. I prepped this right before the workshop, but here we have, for instance, some rain. The rain looks like, if I can grab it. My mouse is being funny. Here, we have this rain effect. It's already set up when you download it with just a movie file in. So this is a rain effect. It's sort of a post-processing effect. I also found this on Shadertoy. And say that I want to graph that, right? I would just grab the whole thing here, copy it. I would put it into a base, which I already did. So here it is. No longer using the movie file in, I have an in instead. And then I would just have this effect now. So now if I put anything else in, so let's go back to the one I just copied and put that there. I'm now going to put that into the in top right. And now I have that effect on shaders. What's really nice about this is that before I even have to begin to edit a shader or rewrite a shader or get used to some of the concepts and learn from others, right? I can already see here what the FPS is going to look like once I begin stacking those effects. So it's like a little effect engine. And secondly, there's a separate tool in here. And if you just scroll right, you will get the pie shader part. So if I now click make pie shader, you'll actually get the same shader code, in this case, this one, and you'll get it here for Raspberry Pi. That means that over here, you can now just copy paste this and throw it onto a Raspberry Pi for the library that I built. How are we on time, Bileam? Should I show the Pi stuff live?
Like 5 minutes left.
5 minutes,
yeah,
okay,
go ahead.
Good. I will show the Pi. I actually haven't tested this one, so that'll be fun. TouchDesigner I use for prototyping a lot because you'll get here it outputs the pixel shader code, the fragment code, and you'll get here this one compiled successfully or it did not compile successfully. It's missing something on line 74 or whatever. Raspberry Pi not so friendly on the whole, giving feedback on Pi, but all these things do, if I was to just dive into them, is that there's a chop exec here that literally is a glorified search and replace. So I just have done a lot of research to figure out exactly what kinds of GLSL things do a Raspberry Pi need to know, for instance. What kinds of things do TouchDesigner need to know? And it just adds in the sort of TouchDesigner only variables. Like we need this sentence for line, for instance. For Raspberry Pi, it needs to get uniforms in a certain way. So basically, if I spin up my VNC, my Raspberry Pi should be on over here, hopefully. and we just log in. So I use VNC to be able to copy paste between them. And here is the Raspberry Pi. Then I've gone to my GitHub and I've downloaded the tool. It's completely open for you guys to use. And I have examples here. So if I open the all uniforms examples and I open the Pi part here, we'll be able to run it and see. And then we're just gonna grab one of these and we're just gonna copy paste it by hitting Control on a Mac. And we're just gonna call it something else, right? This is the name of the vertex shader and the fragment shader. And we don't care about the vertex shader at all because these are all fragment shaders, meaning they talk to the pixels and decide the colors. And then we're just gonna, oh, that's not the one I wanted to open. This one. We're just gonna go ahead and delete all of that, save so it's empty. Then we're gonna go ahead here to wherever it went. Now we're still on the same screen. Here, we are gonna go here to the Pi shader code, which is also, it's just the same as this. And we are going to go ahead and command grab all of that, copy, go to here and Control paste, and then we're gonna save it. And once we've done that, hopefully, one little change that we still need to do, we need to tell it which shader to run. We named it test. We are gonna do test, and it may run, it may not run. If it doesn't run, then it goes into my GitHub. Why did it not run? And then I add more things to the tool to make it automatically search and replace. So we'll see here, run. If it's black, it doesn't run. It doesn't always work because all of these shaders, they'll be worked, run in a different manner. But this is what you'll see if it doesn't run. Then you are, unfortunately, because like I said, Raspberry Pi does not have like a nice way to give you fragment shader compiler error info inside of Genie. So you are going to have to figure out what is the matter. But so if you run one of the other shaders, like I know Shadertoy one is going to run because that one is this one that's running here. You would do this and it will run. And then this will actually, if you run one of the other examples, would actually be able to be output onto one of these pixel screens with this library. So yeah, sometimes you have a little bit of extra work to do on the Raspberry Pi side, which I'm still working out because this is new. Nobody really does Raspberry Pi shaders. It only became like really possible with the Raspberry Pi 4 because it has a pretty beefy, very tiny graphics card. So this is sort of the first way to do this. It's impressive because it should be able to run on a 4K screen actually. So that's why I got into this at all. Yeah, so I'll be adding that shader to my issues panel on GitHub, which I really implore you to try this out. And like, if you find any issues, add them because I will go in there and I will fix them. So this is meant to be a community tool to get you quickly prototyping with shaders, to get you into to TouchDesigner. That's not what I wanted. To get you into TouchDesigner here and start, of course, like editing this code, right? So you have the code here now. It's copied there. If you never press this button again, you're never going to change it. But you could go in here now into the shader code, which is also what I have here, and you can begin to mess with it, right? Like I want to know what happens if this number is 9. Maybe I break everything. we'll see. Maybe it does nothing. Huh. Like I said, this is completely new. I just found the shader this morning, so I have no idea what it does, but it makes me able to dive into TouchDesigner using shaders and learn from this one. And this is actually how I learned shaders, because there isn't like that good shader resource for us. So we'll see.
All right, thank you.
Yeah.
Really, really nice. Like that the kind of the last sentence, kind of what I was like gonna ask, because I've tried to get into shaders in a number of times, and I always like gave up pretty quickly. So it would be like a question if you know any like good starting points. Like you also said you made like this booklet, right?
Yeah,
Could you share
definitely that? Yeah, it's I can share the link in the
book of
chat.
shaders,
It
I
is,
know as well.
Book of Shaders is great, but I feel like that research, that's how I learned. And it's great, but it doesn't explain to me in a language that is for a non-mathematician or like a non-computer sciencey person. So if I just like figured out how in processing or TouchDesigner or whatever to make a square on the screen and make it red, then like not even using shader, just random code. I'm like, oh, but I want something to move on it. Like I don't want to put a video on there. I want to put something generative on there. Then like that was a gap. So the booklet of shaders, or the P5 shaders JS, is trying to fill that gap.
Nice. That's great news. I definitely want to get into it again. It's just like, I mean, it infinitely expands TouchDesigner, so it seems like the perfect tool if you want to get it deeper into generative graphics and stuff. So yeah, thanks a lot.
That's what I use it for. It's fantastic for rapid prototyping. Honestly, it has completely changed the game for all the companies that I work with in this.
Nice, thanks.
Hello. So this is awesome too, because I feel like I normally when people ask for shader references, I always pass along Luis's project. Yeah, I feel like you've done such a good job taking what is normally a really hard topic to approach and then breaking it down into terms that are really, really easy to understand. So definitely also check that out as well. That like intro P5 piece. Yeah, it's awesome.
Really nice. All right, so stage is yours.
Cool. I'm Torin. I'm Peter. And yes, I'm so excited to be here. This is really fun. We got a chance to do an in-session a while back, kind of getting to work out a couple little details in this project. But I guess first we'll give a little like personal intro, and then we'll jump into the project that we've been working on, and then how to use that in TouchDesigner. So yeah, I'm a creative technologist and media artist. I kind of work doing a combination of like design and programming, and also some education in that space. It's like teaching creative coding, and then also recently teaching a class on TouchDesigner, which was really fun. There was a group of students that petitioned to have this class offered at Parsons, and I was like, all right, let's make this happen. So that's been a really fun experience recently. And also a lot of my work has kind of gone similarly to Louise, trying to be like tool agnostic, like learning these content and trying to be able to like move between platforms. And really had an incredible time working with Touch. I feel like it just provides such a great ability to rapidly prototype things. And my work with Touch has been around recently collaborating with a studio doing installations in hospitals. So we've actually gotten to use Touch to build out like a capture system in a neuroscience lab, and then also as like an interactive piece for a children's center. So when these kids are doing their like physical therapy, they can have like an interactive wall to be able to play with, to hopefully distract them from the experience a little bit, but also moving towards the direction of using it as a tool to help them in their rehabilitation process. Yeah, and it's just been so fun to also have the community of Touch to be able to like get feedback and yeah, on these pieces. Yeah, Pete, you want to do a little intro?
Yeah, I'm a software engineer that does a lot of work in graphics and machine learning. I've been doing a lot of shader and graphic stuff since university, and it's something that it's kind of at the intersection of a lot of my different interests. So excited to be contributing to this and helping out.
It's awesome. Pete was like on call earlier. He was doing some research for the Times, and they're basically doing a bunch of analysis on the Olympics. So they're like capturing a bunch of the imagery and then setting up a whole pipeline to like analyze it and then get that out. So if you see any pieces in
We just published a New York Times article with some race 100-meter speed analysis this morning. So
yeah,
can see that on the website.
Yeah, you can check it out. Cool. So I guess kind of going into like our background on this, Pete and I met at university, and we were really looking for like a community to kind of do art and programming. We didn't really feel like there was that available. I feel like now there's like whole degrees in like creative technology or like being a creative technologist, which like wasn't really a thing then. But we really tried to carve out that space. And so we started teaching like a weekly meetup at university, doing like a combination of shaders, Shadertoy, 3JS, things like that, kind of in the general graphic space, but trying to teach it to a group of students. We're getting some nice little lens flare in there. Let me shift this way a little bit. Wow, it's quite the lens flare.
Not even a shader.
Yeah, not even. Yeah, that's some good lighting. Yeah, we'll scoot sideways. The skylight's just blasting us right now. That's funny. Yeah, we were trying to kind of carve out that community, and we ended up teaching these weekly workshops. And from that, we had a similar experience. Like shaders are really kind of like a scary topic to get started with, and there's not a lot of good resources. And so we kind of started making this tool. The initial prototype was born out of that group, and the goal was to be able to kind of like quickly create these shaders and like live collaboratively edit them. And it's grown over time. And what we noticed is that there's a lot of repeated code when you're creating these shaders. You'll see people pull from a lot of Inigo Quailes's resources. He has like a really great set of references. And so we were like, imagine if this was built like a framework or a library that would allow you to kind of like reuse this content and also start from have kind of a lower barrier to entry to start. So we created this tool called, inspired by Shadertoy, obviously, but it's called Shader Park. And it basically allows you to create interactive 2D and 3D shaders, but using JavaScript. So we were also inspired by tools like P5.js and processing and kind of their programming style. And what you can do with them is you can script them really quickly, and then you can also embed them, and they are interactive as well. So the goal is to kind of be able to use these in your sites. If you want to embed it in a website, you can do that. So you can kind of like add these different events. And we also wanted to kind of bring in these community aspects as well, so that people could create this content and really quickly modify it. So like here, just as a little example, we have like our in-browser editor that we've worked on, where you have this little 3D environment where you can start creating your pre-marched graphics. And these, so there's a, from this talk, I want to make sure that you kind of have a takeaway of 3 core concepts. So like, what are shaders, what is ray marching, and what are sign distance functions or sign distance fields? All 3 of those come into play for this. And then we'll kind of show you how to be able to play around with these things in TouchDesigner. So if you, let me share a link to the site as well. So if you go to shaderpark.netlify.com, you'll see kind of our gallery of featured sculptures, and you can go to any of them and you can click into it. Or let me put that in the chat. Thank you. Cool. And you can click into them This is a little iPhone one. Let me find another one really quickly. That's actually like two of them kind of blended together. You can, what's a good one to start with? Yeah, you can click into them and then kind of view them in 3D. And if you click on edit code, the code editor will open up and then you can live edit all of these. So it is using JavaScript, but we've kind of behind the scenes, we're writing shader code for you and then handling a lot of the setup process. So ultimately, like if you want to make a Raymarched shader, you can start by just making a simple shape. So to be able to get to this point where you can just write a single line of code and be able to render this is like, there's a lot of groundwork to be able to do that. We basically have built like a whole API to be able to kind of take these, to create these shaders. And so there's also like a whole documentation page that you can go in and kind of see how to play around with these. But what I want to do is kind of put this in terms that you're used to in TouchDesigner, so you kind of have an understanding of like how this works and how to play around with these. So I guess first talking about, let's go over like ray marching a little bit and sign distance functions and like what are the unique things that you can explore using that. So I guess, yeah.
Do you want me to? Yeah, sure. Talk about that. Yeah. So the first thing I'll say, there's a lot of things sort of going on here in Shaderpark to make all these graphics come together. But kind of the two big things are, one is that you're actually able to write shader code in a limited capacity in JavaScript. So like there's this sort of element of like you can write your same sort of mathematical expressions or functions, whatever you would write in a shader, but you can write that in JavaScript to produce a 2D or a 3D shader. And then in addition to that, this library has built in this basically processing style kind of imperative API for creating 3D shapes, 3D graphics using a representation called sign distance fields, which is an alternative representation for a 3D model to like say a mesh, for example, which is made of triangles. And they have a lot of really nice properties in what you can do with them in terms of like distorting objects, combining objects, blending between the objects, like in that example there. And generally they kind of require like there's a lot of kind of boilerplate in writing shader code to create these, but basically in addition to actually being able to do your shader calculations, write a shader in JavaScript, it also has this very high level and like sort of processing style where it's just an imperative, like you call box, you call sphere with like size and other parameters to create the object. And this basically saves you from writing a lot of boilerplate shader code.
One thing that's really interesting with that process is normally when you're writing a shader, you're like, okay, I'm given the coordinates of this, or at least for a fragment shader, you're like, I'm given the coordinates of this pixel. How do I want to use this so that it's going to run on every single pixel? And when you're working with it in this format, you don't have to really think about it in that same mindset. You can kind of go back to thinking about it as like a shape or how you want to start to combine these different elements. And because we're using a higher level language to create these, you can actually use some really interesting techniques here to kind of like combine these elements. Like you can use functional programming to start to create these shapes.
So yeah, a lot of this is examples here of constructive solid geometry, which you may or may not be familiar with. It's like a common thing in 3D modeling CAD software where you basically can take different solid 3D objects and like take like say the intersection, like the place where they're like both meet, both fill the same space, or the difference where you like subtract one shape away from another, and this allows you to do that kind of thing with, you know, moving, animating 3D objects in real time a bit.
Yeah. So I guess one of the things we wanted to show is just now, like, what's the connection between this and TouchDesigner? How does that work? So let's go ahead and dive into some of those examples. So what you can do, we have this project here, and I'll put that in the chat. And it's like a full starter kit for using this in TouchDesigner. And we basically built a plugin, but also wanted to make sure that you had kind of a nice overall project to use as a starting point. And so I'll really quickly show you how to get up and running with it. So if you go to this link, you'll go here and you can just download it as a zip if you want. And what we ended up doing, we wanted to make sure you didn't have to like install Node or anything like that. So we actually bundled together the whole, like a whole Node.js environment into this. And the way, you don't have to use any of these. Basically, all of your work is going to be inside this distribution folder. These are all just like tools to help build the component. So this is our nice touch project right here. And all you need to do to get started is take this zip, unzip it, and take these 3 and just drag them into the main part of the project. And then we can even delete that distribution folder. So this is a little tool that the TouchDesigner project references, and it will convert your shader park code into TouchDesigner's setup. So if we open this, I already have it open, so that way we can kind of jump into it. You'll be greeted with this project. So the cool part about this is that you actually get to see a lot more under the hood how this is working when you see it in TouchDesigner, because a lot of that is kind of covered up behind the scenes when you're seeing it in the browser. But the core component right here is this shader park core, and this handles converting that code into a shader. And so you'll notice here that it, what I can do, for example, is put down a text dat. And I can write like, let's do like a box of like 0.2, 0.2. And then if I connect it, it will generate that shader for you. And you'll see here that like it's basically generating a pixel and vertex shader for you. And then those are getting passed into this component here for the PBR shader. And then we're applying that to the material of a cube. So one thing that's a little funny here, like normally when you're seeing these objects, like I guess the main distinction to think about here is that there's no like points that make up this object. Like normally you'll see like 3D objects like this working with SOPs, and that's like a very different approach. So everything that you're seeing here in this shader is rendered to the like inside a cube, like a little cube, and it's applied to the surface of it. And we can kind of show you a little example of that just by opening up the editor again. Notice that when you scale the size of this sphere, it's actually, you can see the bounding box of this. So yeah, basically we have a cube, we're applying a shader to it. And then because we're doing some little magic here, when you change the camera angle, you're still able to see the actual shape. One thing I think that's really fun to kind of demo here is like how to drive some of the input with TouchDesigner. A lot of the time, so when you're working with a shader, it's kind of a bit of a black box, and there's only a very specific way to send inputs to it. So in this case, if you go to like this PBR GLSL, you'll notice that like there are these vectors and these uniforms that get passed in. So this is where you kind of handle those inputs. And what I can do really quickly is kind of make a little example to drive that. I guess, how are we doing on time so far?
I got like 5 minutes, I'd say. 5 to 7 minutes.
Cool. Maybe I could do a little example that's kind of similar to something we did during a music hackspace workshop.
Yep.
So cool. Okay. Let's try that out. So, all right, I'm gonna show a quick little like live coded example. Fingers crossed it's gonna go well because I'm just doing this on the fly. But basically what I wanna do is show you a comparison of like how noise would work in something like TouchDesigner, and then how you can kind of create this 3D animation and drive it with audio analysis. So it's a lot to do in 5 minutes, but we'll see if we can kind of explore that. So I think one of the first things to explore here is just the fact that we have the ability to kind of, like when you're seeing this object, you don't realize that it's, you can kind of like play around with it normally, but I think that one of the main things that shows how this is operating on every single pixel is when we introduce this concept of like, that Pete and I named like get space. So we'll call it a variable S. And you can do some really interesting things with it. But the main thing here is that we're going to sample a noise function, and it requires like a location. And so we're kind of like sampling out in every point here.
If you're familiar with shaders, you can think of it like a 3D frag chord. Basically, it's
Definitely.
your position in 3D space.
So what we can do is actually use a noise function to kind of break up the surface of the object. So here I'm changing the size of the sphere. If I add in our noise, and I'm going to scale it down a little bit to like 0.2, you'll notice that it starts to like distort the object. And this is very similar. So like in Touch, if we have the noise top, this is very similar. I'm going to try scaling it, but notice how like if I take the period and I increase it to like 10, you'll get kind of like this like softer shape here. This is very, very similar. So if I, it's kind of like the reverse here. So if I multiply this by like 2, now I start to get these like finer grained details to the point where I can kind of have this like little noisy shape. But we'll start small. And the other thing too is like, there's this fun technique in Touch where you can like take this shape and then you can sample your previous noise function just by passing it in here as the second parameter. And I think it works a little bit better if I just use the original noise again. And you get kind of this like doubly nested noise. And one thing that's really cool is that the way that actually works in code is that you take the noise function and you sample the noise function again. And then you start to get
magnitude down a little bit.
Yeah, we'll scale it down a teeny bit. You start to get the similar like rippling effect. And all of this works as well with time. So if I add in like time times 0.2, you can start to animate this shape. And one other thing that's really fun here too is like instead of working with the individual pixels, we can also use another variation of this that we'll sample from the camera. And what's cool is I can swap that out instead. And now this will change shape based off of where the camera direction is. The last thing I'm going to do really quickly is just swap this out with, add a little bit of color. So I can do, add in like a little bit of green and maybe some blue, and I'll color with this value here. And the other thing I'll add in maybe is like a little bit of the normal. And then kind of scale this a little bit. So I'll take the first noise function and scale it up a little bit more. Maybe I'll take this one and scale it down a little bit. And what we can do here is any of this code will now like run in the TouchDesigner plugin. So the way to do that as well is to get an input. So we need to kind of create that uniform. And what I can do is I'll just name this audio. And I can create an input, and notice that I get like a little slider here. And everywhere that I was using time beforehand, maybe I'll add in time here. So we get a little bit more motion. What I can do is swap out time with audio. And now notice that I have this little slider here that I can use, and I can kind of drag through it. I can copy this and paste this into our text app. And we need to just add a input here. So I actually had already created this beforehand because I was just kind of exploring this, but this variable here for audio, we need to create in TouchDesigner as our input. And so what I can do here is just go into this little PBR component, hit the plus button, and I can type in the name audio. And notice that as I change this value, it's going to update our shader. And
sorry, I think we slowly have to get to an end.
Okay, sounds good.
We can answer questions.
Cool. I can just drag and drop this and pass a link. And now I'm driving this with some audio reactivity. Yeah, let us know if you have any questions. I feel kind of like it's a lot to cover in a period of time like this, but yeah, any of these will work in the TV plugin as well. So super excited for you all to get to try this out, and love to hear your feedback on it. Thanks.
Really, really cool. Nice. Thanks for sharing and giving an overview. It's very exciting, and I think, I mean, it's kind of this community thing, so it's going to get more interesting even when more people are using it. So I think it's a great start. Like there's a lot of people sharing their stuff on your webpage. So like it's completely online now, right? Because when we talked, you said it. We're like, yeah, okay.